Okay, hello everyone. It is 2:47 on my cell phone, so hopefully that means we're almost on time. This is kind of going to act as my clock, so I can stay on time. Wait, do I need anything else? Do I have all my little props out? Oh, my notepad, yeah. I mean my tablet. Yeah, very fancy. Put this right here. Okay, we're good. They're bringing in some chairs in the back, so if you cannot hear me, just tough. All right. I am Toby Schnars. I'm here from Prism Engineering in Philadelphia, and today we're going to talk about using layout sketches to drive your assembly design. Now, there's a couple of different techniques for this concept. The one that I'm not even really sure what the name of the session is. You guys should have a little eval here. I'll give you some of the info you need for this eval, but you can just put, something like this, driving assembly design using layout sketches, or that's fine. Something along those lines. Now, the level of expertise for this class is intermediate. And to qualify that level of expertise, what you really should have is some experience with creating assemblies using in-context references, and hopefully some frustrations with using in-context references and assemblies, especially when it comes to file management, trying to reuse those parts or those assemblies on another project. And this lesson today is really going to address a lot of those frustrations and alleviate those frustrations, and you can use this technique over and over and over again. If you're a beginner, if you never made a part or an assembly, you're still going to appreciate this info, and you'll certainly appreciate hearing my voice, but it'll really hit home with those of you who have created assemblies, and especially if you've made in-context features in your assemblies. It's not a lesson on managing those in-context features, though. It's a lesson on using a sketch to drive that assembly. And really, we're going to talk about what this technique is, but to sum it up, what we do is we create a single part. We make simple skeleton sketches in that single part, and then we insert that part into our assembly as the first part. And subsequent components that we insert into our assembly are all going to be referenced back to that one single part. So you don't have the leg of the table referencing the bottom face of the table and the skirt of the table referencing the leg. Everything is referencing back to that one single part. And that's really the key to ensuring that your designs are robust, right? My friend Matt, I saw him walk in. Matt, where are you? Raise your hand. There he is. We were talking yesterday about how much more robust this design is. Now, what I've done for you guys is put together an agenda here, but I've also put together a PDF of notes on today's presentation. This is my smartphone here. You can see that he's acknowledging how smart he is. And the reason I drew that on there was just to show you that right now, you can pull out your smartphone, you can go to prismeng.com and you can download these notes. So if you have a smartphone, or a tablet or whatever, pull it out right now and you can go and you can download these notes. And that way you can really focus on the presentation and we can keep things moving along without having to feel like you're scrambling to get all these notes in. Now we're going to leave this up on the website until Friday, till the end of the week. So if you don't have a smart device with you right now, go back to the hotel room tonight, you can download these notes. But a lot of the presenters I noticed were saying, oh yeah, they'll be up sometime, the presentation will be up, you can download it. You can download this right now. Here's my smartphone. This is I'm going to my smartphone on this video right now. Looks like I have a text message. I think it's probably from you, Dan. And when I go onto my smartphone here, I go to www.prismeng.com and I can download this PDF of all the notes for today's presentation. So all the little tips, tricks, advice that I'm giving you, the steps in the method are all in this PDF, and you can download it right now and follow along with it during the presentation, or you can download it once you get back to the room. And like I said, the goal of this is so that you can really focus on what we're talking about and you don't have to feel like you're playing catch up, taking down all your notes. So you just go to the website, you zoom in on the handsome guy here on the middle of the page, see him there? That guy is so good looking, I'll tell you what, man. And then you just click on the button for download. It didn't work for me when I did it from my phone. I had to click on the little arrow, the words. But when I did it, on a different tablet, it worked fine. So there it is, got it. All right, and that begins the download, and then you'll have the notes. Okay, I'll leave this up for 5 more seconds. So the basic agenda here: intro to the method. Why you would want to use the method, what would be the benefits over a different technique, how to do it, the step-by-step, and then an actual SolidWorks example. And we're also going to get into maybe a little bit more of an advanced topic, which is multi-user simultaneous collaboration. And you might sound like that's something that's not possible in SolidWorks, but you're going to see it here live. And we're also going to talk about how to take images of a project and kind of reverse engineer a project from those images into a SolidWorks design. So who am I? I'm Toby Schnars, Tobias, son of Robert, up from Pennsylvania, or from up in Pennsylvania. And I'm also a SolidWorks Elite AE, which was a big accomplishment for me a couple years back. And to get there, I had to get a number of certifications. So CSWP, how many CSWPs are there in the room today? Okay, good. Excellent. Excellent. All right, and I also got my tech support because I'm on the VAR channel, and associates, expert, instructor, sales. I got sales, that was pretty cool. Composer, all the auxiliary CSWPs, I got all of them. I got the CSDA for sustainability, enterprise support, simulation support, workgroup support, plastic support, electrical support, draft site support. That was a fun couple of days. CSWSI, sim instructor, and earlier this year I got marketing, which was very, very helpful for doing these types of presentations, for posting videos. I want to get the information to you, the end user, in the most efficient manner possible, and the marketing one really helped me understand some key points. But, setting these goals is important. I like to challenge myself to learn new areas of the software. But the real reason I do this is just so that when I get an email from my boss, and he says something like, you go into SolidWorks World, I can reply and say yes, and then use my signature file. So that's the main thing that I like to do with that. All right, of course, I have to also offer some thank yous to the other presenters. Saw some great presentations this week. To SolidWorks Corporation, right, and 2 and 3. I'm sure some of you guys have seen that, right, Doug? And also to you, the audience, the end users. Thank you all very much for coming and attending. And as far as inspiration along the way, there's really 2 people I've had a lot of conversations with about this method, and that would be Lou Gallo, who I used to work with at DDI in Arizona, and Neil Sardinez, who works with me in Horsham, Pennsylvania. And Neil is really, he's a Jedi of SolidWorks. He modeled an entire locomotive, a steam locomotive. It's a 1917 Pennsylvania Railroad B6 SB. And that has to do with the number of wheels and where the smaller wheels are and the larger wheels that code. But he's modeled this entire thing in SolidWorks, and it's functional. I mean, it doesn't produce steam, but the mechanisms are all fully functional, which is amazing, and it just goes to show his aptitude at SolidWorks and assembly management. So he and I really talked about this method. And if you have any questions about this method, you're going to have to hold them to the end, because we only have an hour to get through this. And I've allotted 10 minutes at the end for open question and answer. But until that time, just hold your questions. So what is this method that I've been referring to, that I've talked to with some of my mentors, with some of these SolidWorks Jedi that are out there? The method could best be described as the skeleton sketch part master model layout-driven assembly method. Quite a mouthful. It kind of reminds me of the Essentials class when they say SolidWorks is a parametric 3D solid modeler that takes advantage of full associativity and all those words in Essentials. The method is you take a single part and you make these layout sketches in the single part. And then you use that single part to drive in-context components in your assembly. So this is what it'll look like in SolidWorks. SolidWorks is going to have to launch here, and I'm probably going to get prompted to log into PDMWorks, so just give me a second. In practice, this was all up and running, but in the real world, it gives me a chance to get my water. I'm leaving. See you guys later. No, still here. Didn't really leave. All right, here's the first example. This is Workgroup. Workgroup PDM runs pretty sweet on a single laptop. If you want to use Enterprise, that's great too for a company, but just me, so I'll just use Workgroup. Table example. So in this example here, like I mentioned in the introduction, the method is one that is defined by taking a single part file and drawing in some skeleton sketches. These are 2D sketches. You could certainly use 3D sketches, but I wanted to get the point across that that's not a necessity. The 2D sketches can be used to drive all the geometry in your model. So in this example, what I did was I started out with a floor plane, and then I indicated the height of the table, floor plane, height of the table will kind of work together, and the outside perimeter of the table. And then I created a sketch that represents a skirt that kind of sticks down, made of a different material, helps to strengthen the table, reinforce the table. And then I've got this front view layout, which is giving me the diameter of the leg, the table thickness. You notice how I'm going into my sketch dimensions here and assigning some additional annotations. So it's very clear when I'm looking at this sketch what variable I'm actually changing, as well as the width of the 2 legs. And then I finish off by creating the geometry that I would use for the sweep path of that leg. And by taking this single part and then putting it into the assembly, I can quickly make changes. Let's say I'll just make a simple change here and change this to 80, and then I'm going to return to the assembly. So I return to the assembly here, and there's that change, and I guess it wasn't that easy to tell that there was a change there because the other window was open, but here you can see that the sketch for this is going to be at 80. I can go in and I can edit this sketch as well, and then I can see these updates take place in real time when Instant 3D is turned on. The thing is, you have to be in edit part mode to see the Instant 3D real-time edits take place. So there you saw that it required a rebuild. We're here and now I'm editing the part, and I single click on this sketch and I can make it 40 and it updates in real time. So very smooth way of examining your designs, sharing these designs with your customers. But probably the best thing about this technique is just the ease of reuse. And you get that ease of reuse by intelligently naming your parts within the tree. So computer, magnify. So if we look at the tree here, you can see that I've got X table, X table, X table, X table, and that's what is going to allow me to very easily do a pack and go. Computer, demagnify. So I go in here to File, Pack and Go. And when I go to File, Pack and Go here, I can utilize this command, Select Replace. And so from Select Replace, I can go through this list of file names and say, look in that list for X table. So I'll do EXTABLE. And then replace any file that has that name, X table, replace that with, let's see here, I'll call this fold table 1. I'll just call it fold tab 1. So replace all, it goes through and it renames all those with, fold tab 1, close and save, and that's going to save it right into my C working. And just to show how robust this technique is, I'm going to open up that assembly at the same time. So they're both open in RAM at the same time. And hopefully everything doesn't blow up. It's a miracle. It worked. All right, so I can go to either one of these. They're obviously not referencing one another now because of using that pack and go and because of the file references. Now this isn't purely used in this type of a method, but it certainly shows the power of this method. So now I could go and I could edit this part again so that I get that nice in context, real-time 3D. Let's say I go to the leg here and I change the leg diameter to 2 inches and maybe change the leg spacing here to 40, and I'll go to the top layout and change that from 80 to 100. Nice long table there. Pretty cool stuff, right? And that's the intro. That's the method that we're going to talk about today, and we're going to go through and teach you, start to finish, how to utilize this method. What are the steps that you need to take? And you saw as you were coming in some examples of some different designs that I've used this technique for. One of them was the Pinewood Derby track. I used the layout sketch to define where the track starts, where it ends, what the angle is, what the radius is at the bottom, where the ramp is. I use that technique in designing. I have this flip-up stand. I'm not going to pull this off, but I have this stand here that flips out that you can use to hold up your laptop so it doesn't overheat, or so it's a little easier to use with a keyboard. And I just drew that up in SolidWorks by defining the geometry of the. Oh, I just got a lot louder. Oh, just getting older. More mature. So if I go in here, let me just show you what this one looks like. The flip-top lappy stand here. You can see that what I did was I modeled up my laptop. It was an M4400, and it would always overheat on me. So I modeled it up and found the docking station holes and just retrofitted this stand to the docking station holes. So I go through now, and I'm going to create my layout sketch. In this case, I'm creating it with some solid geometry as well to help me with the layout process. And there's some important key areas for this layout sketch. And then what I can do is take that single part and insert it into an assembly as the first part and begin inserting additional components into that assembly. In this case, it would be the components for the laptop flippy stand. Now, beyond just being able to create these in-context assemblies, if you take advantage of this method and some of the tips and tricks I show you today, you'll be able to have these in-context components and be able to create a version of them that incorporates motion. So when trying to determine how best to make it collapsible so that I could put it in my pocket or put it into the side pouch of my laptop bag, I was able to create a motion version of the assembly, turn on collision detection, and even adjust the design. I ended up removing a rib from the other side here, and that way I was able to take this thing and completely collapse it. So these are going to be some of the things that you're going to be able to take away from this presentation today and some of the benefits that you'll get from using this technique. In context, master model, as a single part, take that, put it into an assembly, drive all your other parts in the assembly from that single part. Anybody want to leave? Everybody's good? Okay, wonderful. Now, there are some other techniques that you can certainly use when you're working with an assembly and doing layout sketches of your assembly. And one of those techniques is to create the skeleton sketch at the assembly level or to create the layout and blocks at the assembly level. And I think that you'll find today that this approach that I'm presenting may be superior, and that is to create the skeleton sketch at the part level and then use that layout part to drive the assembly. And one of the big reasons, it might seem like a little thing, but it's just usability and functionality. Here you see I can right-click on this part and I can go to hide component, and that all those sketches hide. Where if you were creating layout sketches in the assembly, you'd have multiple entities that you would have to hide, maybe additional planes, sketch geometry, sketch pictures. You'd have to hide all those things one at a time, where here you can just hide that one component. Now, another concern that comes up that I address in this presentation is the use of bill of materials. So I go insert table bill of materials, and I end up with this kind of dummy part that's not doing anything, right? So how am I going to resolve that for a prize? Anybody know? You got it. Right-click here, properties. You, sir, win one of my business cards. You come up and you collect it at the end. Thank you. So you right-click on that component. You go to component properties, and you can see here that the answer is exclude from bill of materials. All right, and then we hit OK, and now that dummy component is no longer in the bill of materials. So there's a number of benefits to this technique, but certainly those two jump out right away when you're working through this method. So why use the layout part? It's easier to manage the in-context references. Every time you make a reference, you're making it back to that original sketch. It's a pretty safe bet that you're not going to, fill it off that sketch. How often has that happened? You create a reference to an edge, and then later you fill it off that edge, right? And when you fill it off that edge, what happens to the reference? It goes to that SolidWorks color. If you're not a parent, if you don't have any little kids, that color is called mustard yellow, right? You guys know what color I'm talking about, right? So the in-context references are going to be much easier to manage when you're using this technique because they're always going to be going back to that same sketch. And we'll even discuss some additional techniques or strategies to use to help ensure that robust design doesn't fall apart when you make a change. Easier to reuse a data set, including those in-context references. You saw that when I did the pack and go example of the table. So easier to just reuse that data. And multiple engineers can work on the project simultaneously, and we'll show you an example of this today. But to give you a little preview in case your brain's starting to think, how would that work? If you take that layout part and you put it into a sub-assembly, let's say we take that layout sketch, and the layout sketch is of this stage that I'm standing on, along with the podium and the table. And we take that layout sketch and put it into a sub-assembly called table sub-assembly. One engineer could work on that sub-assembly. Take that same sketch and put it into a sub-assembly called podium sub-assembly. A different engineer could work on that sub-assembly. Take that same layout sketch and put it into a third sub-assembly, and you call that sub-assembly stage sub-assembly. And then you bring all three of those sub-assemblies together into a top-level assembly. So you're still using sub-assemblies. If you were already thinking about how that might work, that probably all made sense. And if not, you're just going to have to wait till the end to see it in action. All right? Okay, part 3, how to create a skeleton master model, how to use and reuse it via pack and go. Hold on one second here. I forgot something. Just talk amongst yourselves for a minute. Okay. Just got to do one thing. I promised my one friend, his name is Todd. Some of you guys know him. You know him, right? I promised him I would record the important parts of this. So, just give me a second here. I don't know if this is going to get my screen. Well, he'll have to. Here, Gary, maybe you can just put this somewhere that, if you're just going to point it in the general direction of the screen or the presenter, you'll be able to get it. All right, thanks. Oh, wait, let me see one more thing. Sorry.
One's covered.
There you go. Thanks. Part 3, how to create this master model part, how to use it and reuse it via pack and go. Now, this is the slide that has the most text on it, I think, in the whole presentation. But again, I've provided you guys with this PDF you can download. And of course, in the PDF, I've got the explanation of each of these steps. And we're going to go through today in the presentation an explanation of each of these steps. But certainly download that PDF and you'll have all these steps as well. Basically, you want to start out by deciding on a naming convention. And we talked about this already because that's going to aid when you do the pack and go. We talked about how to create and save your master model layout part. Create and rename your layout sketches. So you're going to make those sketches in the tree and you're going to give them names so that you can easily find them in the tree later on. You're going to apply different colors to each of those sketches. You're going to insert that layout part into an assembly. I made a note in multiple locations here that when you do this step, you want to make sure you save immediately. You're going to exclude that part from the bill of materials, as our friend recommended earlier. What's your name, sir?
From Toby's Tech Talk.
You're Todd from Toby's Tech Talk? All right. That's a monthly webinar that I host. He's not a plant either. That actually just happened to work out that way. And you can see here, you're going to begin designing your other components, and you're always going to insert your components on the front plane. Now, of everything in this technique, that's the only one that's a little weird. It takes a little getting used to, but after you do it a couple of times, it's a piece of cake. And it makes sense. All right, so a simple and a complex SolidWorks example. We're 20 minutes in. We're at part 4 of 5, so we're doing great for time. Here we go. Part 1, decide on a naming convention. Went with cyan for this text box. Okay, got onto a cyan kick. This must have been kind of late at night. So the technique that I use for numbering my parts in a scenario like this is I give my parts numbers in the hundreds. So 001, 002, 101, 102, 202, 202, 203. And that's based on if you're working with sub-assemblies or not. So if it's one single assembly, I'll just do part 001, part 002, part 003. If it's multiple sub-assemblies, then it'll be 101, 201, 301, depending which sub-assembly the part falls in. Similarly, when I make an assembly, I'll do 1001, and the master layout part always has 000. This makes sense, right? Everybody who's an engineer makes sense why you have to have some kind of a technique. But also, you need to have a technique for the prefix. So for today's presentation, I'll use a prefix like SWW 2013 box 000 master layout. So you create and save your first master layout part, and after you create and save that first master layout part, you're going to create and name your layout sketches. So you create your layout sketches, you give those sketches a name so they're easy to find in the tray. Oh, more cyan. Nice. All right, keep your sketches simple. You don't have to have every single detail of your design in these sketches. These sketches should act as an envelope. These sketches should give you the overall size of your design and some key locations, things that you anticipate changing, maybe from one version to the next, or maybe as a customer comes back and gives you feedback on the design. But every single detail doesn't need to be in there. I don't need to have my shell thickness. I don't need to have the top fillets for the lid of this box. Just the basic overall sizes are what are key. And after you get done making those sketches and saving that part, you want to make sure you go in, right-click, and change the sketch color. Now, this is, again, for usability. If all your sketches are gray and all your parts are gray, it's going to be kind of tough to figure out where the sketch endpoint is. It just really helps you to understand which sketch you're working on. Is it the sketch on the right plane, sketch on the top plane, sketch on the front plane, because you've got all these different layout sketches. So with that, let's take a look at this example in SolidWorks. See if I can draw some rectangles. With all those certifications, hopefully I can draw a rectangle or two. So I'm going to go new part in inches here, top plane, begin a sketch. Now I'm not inserting component new, so I don't have to pick the front plane for this one. And I'm going to add a relationship. I'm trying to work on a song about adding sketch relationships. Maybe I'll have it for you guys sometime. Someday. All right, and 10 by 6, that's pretty good. I'm going to have some fillets on the front of this thing, so let's say we'll make those 1-inch fillets. Okay, and that is going to be my top layout sketch. So we'll go top layout sketch. And the more sketches you anticipate having, the more descriptive you want to be. We can right-click on that sketch and go to sketch color. You used to have to do this by going into the line format toolbar and then doing colors, but like 2010, 2011, they made it a lot easier. You just right-click and change the color. So I'll change that color there, make that green. I probably should make it cyan with the kick that I'm on. And I'm going to save this part as SWW 2013-box-001 layout part. All right, front plane, begin a sketch, orient my view. I'm going to do my S key, come up, over, down. I probably could have done that a little bit more elegantly. But elegant or eloquent? That's the one I can never remember. Is it one of them's with words, right? Anybody know? We definitely know one of them is with words. Okay. I'll just leave it at that. All right, so that's going to be the height of the box. This is going to be the height of the lid. And like I showed earlier, a lot of times when I create my dimensions, I'm going to have the same technique of maybe putting on an annotation indicating what this dimension is actually doing. So this could be box bottom height. Nice, like that I in there. Okay, and S key, smart dimension, and create a dimension here. Say that's going to be 2 inches, and same thing, I could type in that's going to be the lid. And so now I'm going to go to this sketch color, change this to a different color so it's easier to see. You know, some colors you probably want to avoid if you anticipate seeing them when you're doing your edits. And this will be rear layout. And then I'll finish off here by going to my right plane, and I'm going to just create kind of a vent hole in the side of this box. And this way I've got a feature that's overlapping both components in this assembly. Just spice it up a little bit. Maybe if this box is for a salamander or something, that'll let him breathe. Yeah, good. Think outside the box, right, a little bit. I'm so funny. All right, so I'm going to create this guy. Create this guy here. This is going to be 1.5 inches. And then as far as aligning it, you know, I could put in a dimension from the back of the box, or I could create some more dynamic setup, like a mid-plane type of a thing. So I could maybe create a line that comes across here and then pierce this. So select one, hold control, select the other, let go of control. And then I can, you know, I could right-click, select midpoint. I like having actual hard geometry there in this spot. It's, you know, this is your master layout. It's going to drive everything. It's worth it to make an actual entity if it's going to make it a little more robust. All right, so exit that sketch, and this is going to be the side slot hole. And I'm going to right-click, sketch color, and I'll make that guy orange. That looks pretty. That's a beautiful color. Save. So that's Control-S to save that thing, and let's see where we are. That brings us up to this point, and now we're ready to take this part and put it into an assembly. So this is step 5 in that 7-step process. We're going to take this part and do insert part into new assembly. So insert this part into a new assembly using the command file, make assembly from part, and you're going to immediately save that assembly. And the reason that step is so important is because, especially with virtual components, I don't recommend working with virtual components in this spot, but you know, it's marginal. It's one of those, if I was doing it, I wouldn't do it, but I'm not going to tell somebody like, no, you're doing it wrong. It's marginal, but I wouldn't recommend using virtual parts. But if you are, and you make a series of virtual parts and then you save the assembly, it may have a different name now. So the virtual part was looking for Assem1, and now it's looking for box assembly 1001, and you end up with those question marks in the tree saying the in-context references aren't updating properly. So save immediately, and then right-click on that part, exclude it from the bill of materials, and then you'll be ready to start inserting your additional component. So begin designing your assembly components using Insert Component New. And in my assembly options, I have the option set up for save components to external files. We'll talk a little bit more about this in a bit, but this is also outlined in the PDF, so you can just follow right along with when you're trying to do this example tonight in the hotel room. You can pick all kinds of stuff from the hotel room, like the computer desk that you get in there, or, you know, depending what hotel you're in. Might not be that fancy. Might not have one of those computer desks, but, you know, a dresser, TV. All right, here we go. Back to SolidWorks. We're going to go Insert, Component, File, Make Assembly from Part. Hit the green check mark. That takes the part that you made, your layout part, it drops it right on the origin. The front, top, and right plane of your part are aligned with the front, top, and right plane of the assembly. Now we're going to go to Save immediately, and we're going to save this as SWW. So here, I'll just press down on Windows 7 because that's going to let me get the same prefix. That's what's important here. And I'll call this 1000 main assembly, main box assembly. Save. And I'm going to go to the command Insert Component New Part. Now when you use this command Insert Component New Part, you're going to always select what plane? Front. Very good. You're going to always select the front plane. That's the whole trick. This is the only catch in this whole thing. Always select the front plane. Even if you're not going to be sketching on the front plane, even if you anticipate jumping immediately to the top plane, always select the front plane when you get to this step. So we go into SolidWorks again, and we go Insert, Component, New Part. Okay, it asks us for a name. I've already got that other one that's got that box name in it, so I'll just use that again. SWW box layout part, and this will be 101 box bottom, or 001, or whatever your technique is. Now I get this icon, which is asking me for a plane. So what plane am I going to pick? Front. Excellent. Front. Even though I know I'm going to end up sketching on the top plane, that's okay. Front. Now, what this step does, adding that to the front plane, it's described in the PDF and it's described a little later in this presentation. But ultimately what it does is it puts me into a sketch on the front plane of my part, which is now coplanar to whatever plane I picked in the assembly. So in this case, it's the front plane of the assembly. Ultimately, by doing that, you're aligning the origin of all your parts to the same spot. So the origin for every single part you make is going to be down in that same spot, that same location. And this is it's valuable and it works. It helps with making the models robust. I'm not going to beat up the point any more than that. I think I've done it justice. Always select the front plane. Now I don't want to sketch on the front plane in this case, so I'm going to exit sketch. Now I'm going to go over here to the top plane and I'm going to begin a new sketch. That's where things may seem a little weird, but when you do it a couple of times, it makes sense. Right click here on this component, so now I'm on this top plane of my new component. I'm going to right click on this line here. I'm going to say select chain, convert entities. I'll press my S key. I've customized my S key. I don't do too much customization in SolidWorks, but this is one area that I will customize. So I customize the S key here, and now I hit extrude. And this is a great shortcut that is not mentioned in the PowerPoint or the PDF, but when you're in an extrude command, you don't have to come over here and choose up to vertex. You can just choose a point off of your model, and it'll go up to vertex. A lot of people probably knew about that, but just show of hands. How many people already knew about that one? Okay, good. So only about half of you. So the other half, that's going to be a real nice time saver for you. You can see that in the pull-down menu here, computer magnify. You can see in the pull-down menu that the pull-down menu shows up to vertex now, even though I never went over there and selected that option. So that's going to especially be important when you're running through and doing all these in-context features. So I hit the green check mark. That creates the first feature in this model. Now I'm going to select this face and shell it, and I'll make that at 0.25. And maybe I'll assign a material to this thing. So right click, edit material, and go down through my list here. I've got some different types of woods in here. Let's say I make this out of pine. It's going to be a nice box for my sweetheart. And I'm going to go to the right plane now and begin a sketch. Always now I'm working completely in context here. I'm working on all the planes of this part. I'm not going back into the assembly planes. And so from the right plane, I'm going to right click this feature, this sketch line, select chain, convert entities. And I'm going to do an extrude cut. And since we're in 2013, I can right click and say through all, and then right click and say through all again in direction 2. And I can right click again to finish that command. And that's it for that first part. And all the geometry of that first part, all the sizes are being driven, everything except for the shell is being driven from this original layout sketch. So when I go into that original layout sketch and make changes, I expect those changes to take place on this part. Now just to show that the second feature that I create, the second model I create is completely unrelated to the first, I'll hide it. Not necessary, but I think it helps illustrate what we're going for here. And once again, I'm going to do this box, SW box. And this is just to help ensure that I'm getting the exact same prefix. So this will be 102, and this guy will be box bottom, box lid. Now what am I going to do? What plane am I going to pick? Front plane, right, very good. Front plane. So I picked the front plane here, and once again, I'm not even going to end up sketching in the front plane. I'm not even going to sketch on any of the standard planes, but it just gets my origin aligned to the origin of the assembly, and that's what I'm trying to do. Trying to get my front, top, and right planes all aligned. So I'm going to go to the top plane of my new part, hold Control, and drag it up. I'm going to pick this point here. You notice I'm always picking points along the left side of my model. You could choose to always pick points on the right side of your model or up the center, whatever. As long as there's some consistency in your design method, when you go back to edit these models 6 months from now, you'll have a better idea of where those references were made. So for me, I always end up picking the left sides. I don't know why, just I am what I am. So select that plane, begin a sketch, right click, select chain, convert entities, S key, extrude up to this point here. All right, and that gives us that feature. Maybe we're going to add a fillet on this edge of the feature, 1/2 inch. You notice the dimensions for that fillet weren't part of the layout. That's fine. Everything doesn't need to be included in the layout, just the key overall dimensions. And then I'll do a shell here at 0.25 again. Just like last time, maybe I go in and assign a material. So this material is going to be mahogany. That way, when she sees it from this angle, she'll be like, oh, nice, mahogany. Oh, pine. Oh. Thanks, Toby. Really nice. All right, and then I'm going to go to the right plane of this part, begin a sketch, and I'm going to right-click, select chain, and convert entities, S key, extrude cut, right-click, through all, right-click, through all, right-click again to finish it. Okay, and I'm done editing this part now, so I can exit back out to the assembly. And that is a nice, simple example of how to, start to finish, create an in-context part using this method. You start out by creating a new part, deciding on naming convention, creating and saving your new master layout part, creating and naming your layout sketches, changing the colors of those sketches, inserting that part into an assembly as the first part right on the origin, excluding that part from the BOM, and then using the command insert component new part to add additional components. Now along the way there I did a lot of shortcuts. So I put on my best suit and I took this picture of myself, and these are my top 5 shortcuts that I used along the way in creating those features. So the S key, how many people use the S key? All right, excellent, just about everybody. Soon once all the hands go up, I'll take this slide off my presentations. But until then, everyone should know about it. If you don't know about it, it's S on your keyboard. And you just press that key and it gives you this awesome shortcut menu. Okay, next, This is the Windows, the snipping tool in Windows 7. And then whenever I draw lines, it always looks like my kids drew the pictures on there. This is my kids. I'm like, guys, look at the camera and look right at me and smile. And they're like, oh, like this? Yeah, yes, like that. That's fine. But yeah, your left hand shortcut. So if you take your left hand and you make kind of an L with your left hand, there's so many good shortcuts that are over there that you're going to be using in this technique, but really throughout your SolidWorks career. Control Tab to change windows, Control Q to force a rebuild, Control S to save, Control Z to undo, Control 1 through Control 7 to change views. In 2013, they have the new, I call it a view cube, where you can just press Control space. And if you press Control in the middle mouse button, that's a shortcut for pan. So, some of these are really nice, like if you hold Control and middle mouse button, that lets you pan. Or in 2013, if you press Control space, it brings up this box, lets you quickly change views. So, be sure to take advantage of the myriad of left-hand shortcuts. My left hand's always just kind of hovering over here. If you have a space ball, just, take a cue from SolidWorks as far as where the shortcuts are and program them into your shortcut buttons on the space ball. This is, again, just kind of a good general best practice. Keep all your libraries in one folder. In the PDF supplement for this presentation, I talk about how to set up your options so when you go to Insert Component New Part, you're not prompted for a template every time. So I wasn't prompted at all for a template. And having all your libraries in one place just makes it easier to back up your computer and move to a new computer. And if you're working in a network environment, you're probably all pointing to the same folder anyway. But if not, if you're just working with the out-of-the-box file locations, take a little time, collect up all your templates and your common libraries, put them all in one spot so it's easier for you to migrate that to another machine. This is a quote up top here by me. I don't know why I put it in quotation marks. But I don't like the blue color because it's functionally inferior, and it's simply because your sketches are blue and they're underdefined. So what I'm talking about here is when you right-click on a part and you go into Edit Part. When you right-click on a part and you go into Edit Part, right now out of the box it stays solid and everything else goes transparent, right? But there's some options you can change. These are also mentioned in the supplement. For example, you can say assembly transparency for in-context edit opaque, so you leave all the parts solid when you're doing your in-context edit. If you're doing a lot of in-context editing, this can be very helpful. And also change the color of your edit part. You can change that color of the edit part in the system options under colors, so it's really clear what part you're working on when you go into edit part mode. These two work hand in hand. It's a preference thing, but I find that it helps with my productivity, so hopefully you will too. That's just, again, I have a whole page of options you should set. It's only 4 options, but I like screenshots. And most importantly, pushpin this thing. Definitely the most important tip you're going to get while you're at SolidWorks World. Okay, pushpin this thing. And then just a couple of additional things. I mentioned this earlier. When your mouse changes to this icon, what actually is happening? Well, a new part is created and inserted into the assembly. The face selected becomes the location of the front plane of this new part. I think everybody's pretty comfortable with that if you've ever done in-context editing. And since this is an intermediate session, I'm sure that everyone's done some in-context editing. The origin of the part whose face was selected, not the origin of the assembly, is projected onto the new front plane, giving you the location of the origin. This is the one I want to review just real quickly here. So I'll go to this traffic light example and do an open checkout. And with the traffic light example, you can see that this first part is not located on the origin of the assembly. And I'm going to go to the command Insert Component New Part. And I'll call this traffic lid, let's say. So when I go to this command, you can see that the cursor changes to that arrow with the green check mark, and that's saying pick a plane where you want the front plane of your new part to land. So I pick this plane up here, and that's where the front plane is going to be. But it's the origin of this part that gets projected up. the origin of this part is projected normal to that plane that I selected, and that gives me the location of the front, top, and right plane of this new part. So maybe you didn't know that before, but if you did, just pretend like you didn't, and you're really impressed. But if you didn't know that before, that can really help you understand what's going on when you're doing in-context edits. So here, if I make this lid for the traffic light here, and then we open that up into its own window, it's not going to be oriented the correct way, or at least it won't be oriented the same way it is in use. So, it's just good to know when you're going to use this technique, what happens when you do the command insert component, new part. These are the things that happen. Also included in the supplement. Save immediately. I've mentioned this already a couple of times. If you don't, you're probably going to end up with some types of question marks in your tree. So the whole idea here is you don't want to start making in-context references and then do a save as and change the assembly name. That's where you're going to run into a jam. If you want to reuse that design, do it using pack and go. That's going to be your best bet. Oh, here's another one of these images, right? always pick your references running up the side here. That's always helpful. I mentioned that earlier. It just helps you when you go back and you re-edit your parts. You could add driven dimensions when you're creating a SolidWorks converted entities type of sketch like this. You could add in driven dimensions, and then you could use those driven dimensions when you go into a drawing. Right? Insert model items. Now you have all your model items, and it's all defined exactly the way you want it for manufacturing. So add the driven dimensions here at the part level, and then you can use those when you make your drawings. Oh, here's another one. Windows 7 snipping tool. Make a motion version of your assembly. This is pretty cool. I mentioned this earlier. This came up one day because I was trying to model I think I clicked 2012 by accident, so it's launching in the background. I tried to model a microwave, and I wanted the microwave door to open and close, and I wanted to have it in context as well. So here you see we've got this box example. We want the box to grow and shrink. Well, we can just make a copy of this lid. And what you'll see when you have this copy of the lid, the first instance is always going to try to update based on the converted entities, but the second instance is not. It's almost just a copy of that first instance. So if I go up here to my original layout sketch and I make a change to this top layout, let me say I do an edit sketch here and change this to 14 inches and rebuild, we'll see that they will both update to that 14 inches. So what that lets us do then is it lets us hide this component, and it lets us bring this other component into place using some mates. So quick smart mate here, mate that guy into place, and then I could do a smart mate here to get the hinge relationship, or just a standard mate. Okay, and mate. And now what we've got is we've got this lid that can open and close, but it will still update when we make changes to the layout sketch. So if I make this guy here 10 inches, rebuild, the lid still updates. Pretty cool. How many people have struggled with that before? Anybody try to do that motion and still have the in-context update? Yep, so that's a good way to do it. Now, we're going to end up with multiple instances in our bill of materials, so what are we going to do? You know it, right? Right-click, exclude from BOM. So we go to this one that we hit here, we right-click, and then we go to properties, and we can just say exclude from BOM, and then we won't end up with those multiple instances. Cool? Cool stuff? You guys like that? All right, cool. All right, so now we're going to take a look at this more complex example. And to help me out with this, I got a couple of my good buddies here who are going to work their machines, and help me create this example. Now, I mentioned at the beginning of the presentation that we would take the layout sketch, put it into a subassembly, and then put those two subassemblies together in the top-level assembly. So in this top-level assembly, we've got multiple exactly overlapping copies of this layout sketch. We've got Justin Lautz here. Sorry, Justin. Should have introduced you guys on the way up. And Dan Wagner. These guys are from Prism Engineering with me, and they're my best friends in the whole world. You know it. And so what's going to happen here is I'm going to take the layout pick, put it into a subassembly called body components, and I'm going to ask Dan to work on it. I'm going to take the layout pick, put it into a subassembly called neck assembly, and I'm going to ask Justin to work on that one. And I'm going to take both of those subassemblies and put them together into this top-level assembly. Now you notice that I still have read-write on the layout pick in both instances. These guys are going to take read-write of their subassemblies. So I should be able to just refresh my subassembly and see all the changes that they made, and hopefully the overlapping regions will update properly when we make changes. But we'll see what happens. So let me just queue up another program that I have here. It's called RealVNC. This is just a nice free screen sharing program. And this way we can take a look at what's going on their screens. 1 second here. I got to close out of this PowerPoint for a second. All right. And let's see, I'll run this on, who's 100? Let's see, okay. All right, so there's Dan's screen. Hello, Dan. And let me launch that again, and we'll bring up Justin's screen as well, so you can see what these guys are actually working on. So you can go ahead and get started if you want there. The password, I don't even know the password. Some of these I just have programmed into KeyPass. All right, so you're 101, right? Okay. And it's not going to be this. All right. And this is going to be Justin's screen. So while these guys are working on it, I'll talk to you guys a little bit about this technique of getting these images and reverse engineering using these images. And again, I can do that because I still have control over that master layout sketch. So you can see these guys are both working away now. They started out with just the subassembly with just the layout image in it, right? Just like what we talked about. You have the assembly, you have that one single part in it that has the layout geometry. But in this case, they both have a subassembly with that layout located at exactly the same spot, right on the origin. So now Justin can work on the one region of the assembly, Dan can work on the other region of the assembly, and at the end we'll see what happens when we bring them together. Now, when we utilize this technique, and this is also included in the supplement, we just go through a series of these different steps. You take a picture of your model, you clean up the pictures I use a program called Paint.net. You can use Photoshop to do it too, or even Paint, but I'll show you Paint.net in a moment. Take some measurements, create a layout sketch using those measurements, and then add the images to your layout part and size them to those measurements. So here's what it looks like in practice. I'm going to just go to my folder here that has some of this info in it. I've got this prep folder. Actually, I'm going to go to this guy down here. And inside of this folder, you can see that I took some pictures, took some different pictures here. What was that one? Ugh, that looks like a fire hazard. Iron Man's down. Okay. All right, so there's a picture of the ukulele. That's this ukulele here. And just brought it with as a prop. Maybe I'll play a song for you guys. And what I'm going to do is I'm going to right-click and I'm going to open this with a free program, Paint.net. And all these steps are outlined. You can just do a Google for Paint.net. And I'm going to use this tool here called Magic Wand. And what this does is it's a color selection tool, and it makes the selection based on a tolerance to that color. So it makes it really easy to clean up your pictures. Obviously, with the lighting, the shade on that sheet, every single color on the sheet isn't exact. So if you ever try to do this with like Microsoft Paint, just regular paint, you know it's a little bit frustrating or cumbersome. But here you can see that I can just delete that background, and it gets everything that was close to that shade of blue. Here's a little bit of shadowing, so a little bit more cleanup. But eventually, you get your pictures nice and cleaned up. Now, while you're doing that, or at some similar time, you are going to let me go in here to the Volt, to the Uke project. How are you guys doing over there? Doing good? Let's see. Is that really true? Do you want me not to show them? Okay, let's see how these guys are doing. Oh, they're doing good. Yeah, looking good. So here in SolidWorks, I'm going to go and I'm going to open up that Uke picture. And when I open this guy up, you can see that what I did was I started out by getting a caliper and taking some measurements of the important regions of the uke, in this case the straddle, and the nut, and then just some basic information on the fretwork. And once I had that information, I was able to use the command tools, sketch picture, and bring a picture in. And it's not going to come in the right size, it's not going to come in the right angle. So within that sketch, what you do is you just start dragging this thing around, until you get it to be the right size and to get it to be the right angle and everything. So let me see if I can cancel that. Discard changes and exit. Okay, good. So then the next sketch here, you can see it says image neck side profile, and I can roll that down, and that's actually an image here that I laid in of the side of this thing. And then what I did was I came in and made the basic shape of the body here. So this is just a spline. I'm just going in with the spline and tracing that basic shape of the body. But what I'm doing is I'm setting up Dan so that when he comes in and creates the body, he can just do a quick convert entities like what I did earlier. What I'm doing here is I'm setting up Justin so that he can just do a quick sweep or a quick loft to generate the geometry needed for that neck geometry. So that's the point of these layout sketches and of kind of tracing over this geometry. You can see you may have to repeat the command more than once. Here I had to make an extra plane kind of going down at an angle to get the headstock geometry, and I actually had to lay an image on that plane so I could trace over that image. But you can certainly have some fun with this, make some fun projects, do a little bit of reverse engineering with some stuff you have at home, and that's kind of the gist of this. Let's see where these guys are. we might have to fill up a little time. You know, whenever I'm in SolidWorks World and I have to fill up a little time, I like to play a song. So you guys like to hear a song? SolidWorks song? Okay. All right, let's see what we can do. This is a song I played last year. My roommates, they always knock me. They're always like, Dad, why don't you write a new song? And I'm like, you know what, guys? Why don't you write a song? I think it's so easy. All right. But here we go. This is a song about sketching. I wrote this song because I think it's really important to fully define your sketches in SolidWorks. So here we go. If you know the words, feel free to sing along, okay? How's that? Is that coming through? Oh. Okay, ready? But hold on one second. It's a bit too low for me. Okay. When you're in a sketch, you don't want it red. You don't want it red. This much is true, but you don't also want blue. And when you're in a sketch, you want to make it black and lock it to the origin using a relation. You gotta add dimensions, you gotta add relations, you gotta add dimensions. You gotta fully define every time. You gotta fully define every time. How you guys doing over there? You need a little more time, or? Okay. When you're in a sketch, you don't want it red. You don't want it red. This much is true, but you don't also want blue. When you're in a sketch, you want to make it black and lock it to the origin using a relation. You gotta add dimensions, gotta add relations, you gotta add dimensions. You know you gotta fully define every time. You gotta fully define every time. Should I do the bridge? All right, one little bridge here. I think these guys will be done. And if you're still left with some blue geometry, just grab a blue point and move it around. Just grab a blue point. Just grab a blue point. What do you see? Is it a line missing dimensions? Or an arc that needs some tangency? Fully define every time. You gotta fully define every time. Thank you. Thank you. Thank you. Thank you. How many more times should I say thank you? Okay. So it looks like Justin's done with his, and he's checked it back into the vault. I can see this looks very nice, Justin. Thank you. And you also win the big prize for being the first person to finish. And that is going to be a business card of mine. There you go. So congratulations. And I guess if anyone has any questions, I will be happy to answer a question or two, and then we'll take a look at the results and see if everything worked. Anybody have any questions? Question? Yep.
Is the song on the PDF sheet?
No, great question. The song is actually on YouTube. It has over 90 hits so far, so very proud of that. A great question. Any other questions?
When's the CD coming out?
CD, I think I need to make a couple more songs, yeah. Maybe I have to collaborate with my roommates a little bit, and we'll be able to come up with some songs together. But another question.
And when you did the dual lids and you drug another one in and you excluded from BOM, the mass properties are still going to show too, though.
Mass properties is still going to show. Okay, that's an excellent and legitimate concern and a great question. Here's a different approach to it. What you could do, whoops, I keep hitting, okay. What you could do there is you could just make a new assembly. So you could do file, make assembly from part, and here you could say, hit the green check mark, there's my assembly, and I'm going to save this guy as similar file name, but then you'll say box motion edition. And so you'll have the one that's the in-context version and then the one that's the motion version. And it's funny you say that because this is exactly what I did with the laptop stand. When I made the laptop stand, I made the one version that was in context, and then I just made a new assembly and I inserted the required components into that new assembly, and now I have a motion version where I can do collision detection. That's a great question, and this would be how I would resolve that.
Can't you just say that will include different components?
Yeah, I mean, ultimately though, this would be a super robust way of accomplishing it. Yep. Yeah, you may have options to exclude from mass properties, sure. Yep. Question?
This is a method considered robust in very large assemblies?
Well, certainly you could use it to manage very large assemblies. It would just be a matter of how complicated you want to make your layout sketches. But I envision it in use for maybe plant layout. If you had a shop floor, you could generate this layout sketch and use it to indicate where the different machines are, and maybe even what the envelopes of the machines needs to be, or needs to match for that type of application. For a large machine design, similarly, you could design the envelope and where certain levels need to be. But for individual details, you still want to save that for the part design itself. You really want to use this as a tool to assist in that large assembly design or any assembly design, but you don't want to necessarily have every single detail in the layout sketches, or it's going to get... one thing I noticed is the sketch master part file starts to get pretty big, 4 or 5 meg as a part file when it's only containing sketches. It just depends on how much detail you decide to put into it. But I would encourage you to start with less detail and maybe work your way up. Any other questions? Dan, all good? All right, no more questions. So here is the, let me just do a window close all here and save everything. Sure, why not? That won't get me into too much trouble, right? Okay, and then I'm going to go over to my Vault view and I'm going to do an open checkout of the top level. So open checkout document, open and checkout. And you can see here that now what we've got is the completed ukulele. Let's give a hand to Justin and Dan. Thank you guys. Great job. Great job. Yep. And now let's see if it actually works, right? So we'll go File, Pack, and Go. And we'll call this one Select Replace. I will look for uke. And I will replace this text with, let's say, X Factor. It's going to be a super cool guitar. Okay, and replace all, close, save. And this is all going right into my sandbox. And so now what I should be able to do is go into that sandbox here and look for that X Factor assembly. And now we're going to try to make a little bit of a change to this design. So let's show this component so we can get into his sketches. And we'll let's go to the body layout. That'll be a cool sketch to work with. Okay, and we really want this thing to look neat. I'm sick of the way my current ukulele looks, so let's get a new one that kind of looks more like one of these guys, like a rocker, a real rocker guitar. All right, and then I can do exit sketch and exit that component. Let's hide that component and see how it looks. And there is my, oops, thank you. There we go. And there's my next ukulele. That thing looks awesome. And you can see that the components that Dan and Justin made line up perfectly, right? This is right where the bridge is between Dan's components and Justin's components, and it just lines up perfectly. It blends in there nice and flush. And that is pretty much the gist of this presentation. Taking those components and laying them together in that layout sketch, you can see this component here, it's a little bit higher on this side because of how the body changed. No problems. And you can make version after version after version of your components. So it looks like they're opening the doors, which is the universal sign for I'm getting kicked out. And if anybody has any questions, come on up. You can get my card. I'll be happy to answer your questions. You can email me. Thank you very much. All right, enjoy SolidWorks World. You guys are great. Take care.